Hi everyone, this is my presentation, The Art of Bypassing Web Application Firewalls. So to start off, this is the content we'll be including. We'll be including a short introduction to myself, who am I, the goal we'll try to reach during this presentation. We'll be going through the basic of the web application firewall and how it works, for those of you who are not too familiar with it. We'll go through the Dojo platform, which will be used to host our simulated WAF that will be used for our practical labs. The bypass methodology on how a payload is created, and the methodology I come up with myself that I use now for maybe 2-3 years. That's been it works extremely well for me, at least. And an exploitation techniques on how filter collision works, and how you can bypass using this strategy, and transformation, for example, excluding spaces in your payloads, and also encoding strategies to manipulate the firewall itself. And at last, we will go through the conclusion of the full presentation. So to start off, who am I? I'm Alex, and also known as the Hacker Brumans. I work at JustWhack as a researcher. I'm also a hacker, bug bounty hunter, and a developer. So to cover the goals on this presentation, we'll be going through on how to understand the WAF application firewall's blind spots. We'll go through the mastering a new bypass methodology, which is the one I come up with myself. Understanding different bypass technologies that you can use. Create your own customized payload adapted to the firewall that you're facing. So to start up, on the left you can see the Kali, which is the laptop. In the middle obviously is the firewall with the little flame. You can see on the right you see the server with the web application that's hosting the web application. So when you're sending your payload like this, the firewall will either let you through, but if it detects that it's malicious, it will decide mainly on those 3 categories. So it will either send you a forbidden page, it will block you, or it will drop your request. And that will be, if you drop your request, it will be hard to detect if it's another proxy, the firewall, or the actual web application that triggers some error. So how the firewall does this is it's using regex, black, and white lists. So a regex is quite easy. It's a rule that is based to detect patterns within your payloads. So it can support a wide range. So for example, on the left you can see a template injection payload, and on the right you see the rule, which is a $sign, a curly bracket, and if it continues until the end of a closing curly bracket, it will be treated as malicious. And as your payload contains a template injection payload on your left, which is red marked, you can see it's got triggered by the firewall, and that is treated now as malicious. So the black and white list works like this. On your left you can send XSS payload, which is having the on arrow keyword, and the firewall will extract all these keywords, for example image, src, on arrow, and alerts, and it will check all these words within its list and see if it matches any of the keywords. If it matches a keyword within this list, for example a blacklist, or it's not matching a whitelist, it will treat your payload as malicious and block you. So now that we have the very basic of how firewall detect you, we will go through a practical lab that we will be using for our labs, and that will show you how you can bypass the firewall, and also how the firewall blocks you in different scenarios depending on your payloads. So to start off, you're having the Dojo platform, and it looks like this. So this is an example of the filter collision lab that we'll be trying out later in this presentation. On the top left you can see user input, which is where you actually write your payload. Next to that tab you have an inspect tab. That tab is used to, for example, if you click on any on the regex or the protection mechanism, you will be able to inspect and see where your payload got triggered by the firewall, to more easily point you to the direction on where your payload is detected, on what part, instead of having your whole payload being detected. So it's giving you more details. On the bottom left, or on the middle left, you can see the lab description, and you can see the goal of the lab. At the bottom left, now you can see hints to point you in the right direction during the lab. you will have the source code, which is a very simple source code. In case the firewall actually detects you, as you can see WAF_blocked, it will give you the WAF.html file back. Otherwise, it will give you the index.html. So on the right, you will see the rendered response. In this case, it's the firewall that got triggered, and you will have the forbidden page. And if you look at the red mark window on the top right, you will have an eye icon together with an icon like a code icon. If you switch between those, you can see the source code and you can see the render page. Currently, it's the rendered page, and it's marked as green on the top right of the red window. So in this tab here is the most important part, which is the actual firewall. And you can see from the left, you're having your red input, and you will have the lines on how your payload is transformed all the way to the output on the right. So first it goes for a blacklist, then it will go for a regex, and then another regex, and then it will go for a URL encode. And you can ignore this last part with URL encode because it's only used to not actually be able to write pure Python code within the source code itself. So you can ignore the URL encode at the ending all the time. So with that said, I'm going for a short demo on how the platform actually works, and we'll guide you through it with an example lab. Okay, so when first opening the demo lab here, it will look a bit different. You can see you don't have your input, or you actually have your input, but it's in different tab like this. You can actually drag these tabs. For example, I drag it here to the bottom, similar to the DOI that I recently showed you. And now it looks similar. You can also take these tabs over here. You're having the source code for the challenge, and you're having the result, which is no response because you haven't sent any payload yet. But you can take this result and drag it to, for example, to your right here. And when you send your payload, it will render the page for you for the challenge. And on the left here, on this window, you're having a little code icon. So if you click on this one, you will see the source code of the actual challenge itself. So, and here you will see the firewall, and you can see our input is this one. So when we're sending our input, it will go through a blacklist first. If we write something, for example, we can write Romans. Sending our payload, you can see it's the same as it was in the original payload. So it hasn't been modified or detected by a firewall. So if we send this one, it should be fine. Render. Okay, we're good to go. If we, for example, check this blacklist now that the firewall use, you can see it's having a simple blacklist with alert, confirm, and prompt. So if it contains, if the payload contains any of these keywords, it will get blocked. So we can do, for example, alert at the end, and you can actually see now Bruman's alert and Bruman's WAF blocked. So now we see that our payload got blocked, and you can see it here on the right. So this helps you understand that Bruman's itself is not the trigger of the firewall. It's not what's triggering. The trigger here is the alert. So it helps you more analyze and understand the details why the firewall blocked you and what part it blocks in the payload. So the goal here, if we read, will be to exploit an XSS and bypass the firewall. So if we do a simple XSS here, I believe we are inside a value tag. We're going to see test. You can do Control F here, will pop up, and you can search for it, and you can have test. You will find test here in the value section. Okay, so we're going to see if it's vulnerable, and obviously yes, it's vulnerable for cross-site scripting. We're going to try exploit it. Unload alert, boom, and we will obviously get blocked because it's containing the alert keyword. So if you click inspect, you can see here, dragging down, it's containing the payload, and you're having alert. So the full payload is working fine, except the alert that I showed you before. So instead, we can use something simpler, like print. And we're sending this one. And this is an important note. The payload will not trigger if you're having the code section marked, because the page have not been rendered. So if you click on the rendering icon or the eye icon, you will see our payload popped. So that's the short introduction on how the platform works. So back to our presentation. Okay, so now that we've gone through a live demonstration of the Duo platform itself and how we can use it for a practical lab, we will be going through the bypass methodology. So the bypass methodology itself will be starting off this. So this will be a very simple image or illustration of how it will work. So on the left you will see your laptop. It will sending a payload to the firewall. So imagine this payload, for example, is a full template injection, SQL injection, XSS payload or whatever. It's getting detected by the firewall. And the firewall responds to you with a Boolean response with like yes and no, depending if it's giving you a forbidden page, blocking you, or timeout, for example. Or if it's giving you the original response of the web application that is vulnerable, you bypass the firewall. Quite simple, right? So we will use a methodology like this. We'll send first, the very first time we'll send a full payload. The full payload will be, for example, a full payload like image src equal x on arrow alert 1. Okay, cool. So we will send this payload here. We will ignore updating it because it's the very first time we're sending the payload. We will see how the WAF treats this payload. It will most obviously block it because it's a very easy detected payload. And we will have to decide what triggered the actual payload, like what part in the payload is the actual trigger. So as an example, if I have a SQL injection and we want to send a payload to the application to sleep for a second to verify that it's actually vulnerable, you will use a payload like this. So single quote or sleep for a comment away the rest. The very first time you're sending this, it will, in 99%, if there is a web application firewall in place, it will get blocked. So, but because it's the full payload, we actually getting blocked on, we don't know the actual part of the payload that is blocking. Like, is it the or, is it the sleep, is it the single quote itself, or is it the comment? Like, what section of the payload is actually getting blocked by the firewall? Where is the trigger? So we need to verify the trigger, and to do this, it's not possible the first time. But if you continue with this methodology, like this, I will show you. You're having the payload, you take it down into all its sections or all its different parts. So you will have your single quote, you'll have your space, you'll have the or, sleep, parentheses, the value within the parentheses, and the suffix, which is the comment. So as you can see here, we have the prefix, we have the space, we have the keywords, that is the SQL keywords, the parentheses, we're having the int, which is the value within the parentheses that sleep is using, and we're having the suffix. If you just look at this payload, the first thing that you probably think is the trigger, which is probably the sleep. So, and that's probably true. Like for me, the first that I see is, okay, a quote combined with or. That's in most cases a SQL injection payload, so it's probably that's probably why it's getting blocked, right? So that's one problem we're probably having. The other one will be, as I mentioned, the sleep. When it's combined with parentheses, it will be treated as, okay, it's a SQL injection payload. Okay, so probably something like this is the trigger that's triggering the firewall within our payload. So how can we make this payload more like confusing for the firewall and manipulate it in some way? Like how can we make sleep into something that the firewall do not see as sleep? So you can use something like a table like this. So the single quote here at the top left, it can be, or everything basically in most cases can be encoded to URL encoded, depending on where your input is. And for the spaces, which is quite interesting, this is most of the time the space is actually the thing that you can manipulate and cluster things together to actually confuse the firewall. So it can be a lot of things. You can have tab, you can have new lines, you can have multiply comments instead of spaces. You can have parentheses, which I will go through in next slide. Instead of or, you can have XOR, you can have or with uppercase and combined with lowercase. You can have the or operator, depending on your SQL. Sometimes it means concat as well, so you have to know the database to actually use this. These pipelines. And the last one, which the one I like the most, is you actually taking advantage of where you're infecting your SQL injection payload in example. So if this is inside a where statement, instead of using or anything else, you actually take advantage of the actual value that you were escaping from. So you're taking, for example, if this was an int-based injection, so for example, we're inside an ID, which do not need a quote, you can take equal to, and parentheses, a full new statement that you knew will be true or false. For the sleep, you can use uppercase combined with lowercase, or you can use a totally new keyword like benchmark to see if you get a time delay from the application. As parentheses, you can encode into URL, you can nest them into multiply parentheses, and you can also use something like this at the end. You can combine it with comments to actually see if the firewall is trying to see where it finds the closing parentheses. So for example, if it sees the first parenthesis, it will look for the closing parenthesis, and depending on the configuration on the firewall, it might actually see the parenthesis, the closing parenthesis within the comments instead of the one outside the comments, which you can use to manipulate and bypass the regex. 4 is also like values or something that you can manipulate a lot. Like a 4, you can take 6 minus 4. You can take 4 bitwise to 0, which will be 4, depending on your SQL again. And you can take minus true, which is equal to 1. True is equal to 1, depending on SQL, but you get a point. So minus true multiplied by minus 4, which will result in 4. Or you can take true plus true plus true plus true, which will be 1 plus 1 plus 1 plus 1, which will be 4. You can also use the comment instead of doing double like minus signs. You can use, for example, a hashtag. So remember the payload we had first, which is a single quote or sleep 4. If we want to take advantage of this we just looked at, we can make a payload similar to this. And I made them for you to understand it much better. I made them in different colors and different Boolean values for you to understand, but I will go through it. So the payload that you have first was the single quote or sleep 4. This payload underneath is exactly the same, or it's obviously not the same, but it's doing the exact same exploitation. So as you can see, it's or sleep true multiplied by 4, and then comment away new line. Okay, so the reason why it's combined with this, it's using this, is because if you look at the first that we thought was our trigger, we're now going to test if this theory is actually true. We're going to send this quote combined with the or sign. And if this is not getting triggered, we know that the firewall is relying on spaces to actually see separate pieces of your payload. If it's still triggered, then we'll go through the process once again with a new theory, and then we'll continue. But to go through this payload, this one is combining the space, or just removing the space in the first section. Then it will use a parenthesis which is green, and that is because everything that is green is instead use of spaces. So, or instead of space, you're doing a parenthesis with a new SQL statement, which will be sleep. Then the pink one represents the one that sleep is holding, which will be true multiplied by a comment to trying to confuse the regex 4. So this will total result will be 4 as a value. Then it's closing the parenthesis that or started, and it's adding the comment at the end. And instead of a space, we're going for a new line. So the methodology over here will be, we will try this payload again that we construct, but now instead of doing the full payload, we will just see if the actual first section will be triggered or not, because if it's getting triggered, we'll have to modify the payload once again. So we're sending the first or statement to actually see or test our theoretical theory if it's the trigger. So if we're sending this here, the payload, it will get blocked. So this proved that our theory works. Okay, so the trigger is actually when the single quote combined with the or, then it's actually treated as a malicious payload. Okay, so now we know this. So the payload is triggered when the prefix is set as single quote mark and combined with a keyword like or uppercase or, and that continues with a special character. That's what we know currently of the firewall. So to test this, if it's correct, we'll send it without the parentheses. Okay, so we're sending this without the parentheses this time, and you can see we got bypassed. So this means that everything that comes after, or if it's a special character, it doesn't have to be any special character, but in our case it was the parentheses, it got blocked. So what we need to do now is we need to try to come up with a solution what we can use instead of the parentheses. So, as described here at the bottom, the WAF triggered when the blacklist keyword uses a special character afterwards, as I said. And that will result in this table. So our payload now bypassed, but the other one did not bypass, which got blocked. So our theory is correct. So the trigger is here within our payload. So now how can we bypass this? And this is for more like extreme cases, because we will be using filter collision, transformation, encoding, or excluding spaces, as you recently saw. So we'll go through all of these techniques and how you can use them combined with these recent techniques that you learned. So, filter collision. Filter collision is, for example, it's very similar to transformation, but it's when you're sending a payload and something within the application itself is doing some modification within your payload. For example, if you can see here at the top right, you're having a source code, very simple snippets. It's taking your queue parameter in the get parameter queue, and it's replacing every double quote with nothing. So it's removing them basically. And then it's reflecting to the page your value. If you're sending something like the payload example here, which will be marked in red, your quotes will probably bypass the firewall, because this payload makes no sense, right? It's S, okay, special character, VG, on, special character, load. So it doesn't make sense for the firewall to actually block you, because the payload doesn't work by itself. But what you do is you're exploiting the actual filter within the backend, and that filter is making this firewall confused. So when you send this to the firewall, it will see this one as valid. But when it reaches this code, it will be converted to the actual page you want, which will be the SVG onload alert comment. And that one will trigger. So to demonstrate this, we will do a practical lab and see how you can take advantage of this. Okay, so we're now on our first real lab, which is the filter collision. So in this lab, we're going to take advantage of the filter collision. And we're going to read the description here. The firewall will detect a certain amount of patterns when the payload is handled by the backend server. The payload will be filtered and modified before being reflected in the response. Okay, so if we send something like test here, we can see, okay, it's reflecting test right here. We will see the source code, and you can see test is reflected right here. Cool. So we're just going to send quick payload and see. Sending this, and we're getting blocked. But it's pretty obvious, right? It's quite an easy payload to detect. But we wanted to see why we're actually getting blocked. And you can see here in the workflow of the firewall, we're getting blocked at the very first blacklist here. If we click on this one, here, I can click inspect. You can see it's blocking alert, confirm, prompt, console, print, and from. And since our payload contains alert, this will be the trigger for this current filter. Okay, so that's our first problem. The second problem is within this one. If we check the next filter, in here, if it starts with an arrow sign, continues with a ladder, it will get blocked. And since our payload has the image tag here, it's actually starting with an arrow sign, continues with the word image, which is a letter or letters. So this one will get blocked, and this one was already blocked before. Okay, and the next regex will be on. So it can, everything that starts with on, a new line, or anything else, and end with an equal sign will be treated as malicious, so it will be blocked. So in these cases, we had the on arrow, and you can see at the bottom it's getting blocked directly. So we're having currently, the only thing that works on our payload is the first prefix and the suffix. The rest is blocked. So if we look at the source code of the vulnerable application, you can see it using a filter as well to actually try to protect itself. It is removing all the arrow signs, opening and closing, before it's being reflected. We can try this one out. So we're going to send a new payload, which will be test, closing sign, X, opening sign, sorry, closing tag, and then, for example, send it. And we're still getting blocked, and that's because this, remember, if it's starting with a letter with an opening tag, it should be malicious, or it is malicious and will get blocked. So we will have to switch this tag over here, send it to the end to make sure it's not having a letter. We'll submit it. And you can see now in our response, it's actually removed the arrow signs as expected. And if we check the source code, you can see it's actually removed. So we confirm, okay, so the filter did work in the backend, it's removing our arrow signs. So how can we now combine this filter or take advantage of this filter to actually bypass the firewall? And as you saw, you can actually see here we are inside a value within an input. So we first need to ask ourselves, what do we actually need? Do we actually need arrows? No, we actually do not, right? We're inside an input tag. We could use something like autofocus, on-click, etc. But in this case, it's actually not specifying any type. So it's not a type search, it's not a type text or email or whatever. So it has no type, which means if we're able to escalate outside here, we're able to specify our own type. So we can try to do that, right? X, escape it, and with the type equal, for example, image. If I send this one. Okay, cool. So we specified an image type. It's having, yeah, it works, right? So if you didn't know this, if the input is not specified with type, and we're able to specify the type ourselves, for example with an image, it will act like an image, kind of. So if we now give it an invalid SRC, like a source, we can trigger on arrow within input, the input tag itself. So what we're going to do now is to reduce source equal to X, for example. And it's not getting triggered as you see in the workflow. It's all good, right? So what's actually the real issue here in the firewall is, first of all, the blacklist, and also the regex here with the onload statements. So what we need to do is we have to come up with a way to actually do like an on arrow, as you can see, equal, and then we'll have a JavaScript over here. This on arrow is getting blocked here. So we can use this filter here because remember, it's actually removing the opening and the closing arrow signs. But if we're using the opening, this filter here will trigger because it's an opening combined with letters. But we can actually use the closing tag. So if we use the closing tag and check the regex, it needs to have the word on. This word here, the on, has to be there for the regex to work. And you can see in our payload we have it here. What happens if we actually send adding a closing arrow sign here? You can actually see, okay, it bypassed the firewall. The payload currently did not work because it's having a syntax error here. But this filter should remove it, right? Because we verified it before. So if we send this one here now, okay, we're checking the source code. X, we escaped, type image, SRC equal to X, and on arrow. So we bypassed the firewall and we're able to actually have an on arrow statement within this vulnerable application. Cool. So what we can do now is it's ending with, for example, our quote here. So we can start with a quote. And what we want to do is we want to have like an alert. So alert once again was blacklisted by the firewall in the blacklist right here. But once again, because it's removing the arrow signs, you can actually just combine or add this one randomly within the string, and it's actually bypassed here within the section here. As you can see, it should be blocked now. Let's see, you don't see it here, but you can move this one actually, and you can see, okay, it's blocked. So what we want to do is want to add one here as well. We're going to do one, and then you can send it. And it looks good to go. Now we're going to run there, see if it works. And it works. So we now exploited this by taking advantage of the invalid filter and took this filter, combined it with our payload, and then used it to bypass the firewall. And to my surprise, this is actually a very common scenario, because when it's a vulnerable application, it's actually making some misconfiguration in the filter itself, or it doesn't have a filter. When it have a filter that is invalid, this is most of the time the case. So it's actually removing something, or it's replacing it with something weird. And you can actually take advantage of this, as you saw now in this lab, to actually bypass a pretty well protected firewall by just exploiting the vulnerable section that you're trying to exploit, because it's using some invalid filter on configuration itself. So now that we've gone through the filter collision lab, as we did here, we will go to the next technique that we can use, which is transformation. Transformation is quite similar to filter collision. Like, it could be, in some scenarios, it could be like almost identical. But transformation, in my eyes, is more like it's transferring something rather than deleting it. So in this case, you're sending a payload, as you can see, which is a template injection payload. It's hex encoded. It contains the, you can see over here, the red mark. It contains the curly brackets in hex encoded form. So if we look at the source code at the top right, you can see it's data equal bytes, user input, which will be your payload, UTF-8, which is the char set. It will decode it, and it will having an argument Unicode escape, which basically means that when Python will decode this byte, it will actually include escape character and make them to its original characters. So if you're having hex version of the curly brackets here, you can see it will be transformed into curly bracket itself. So when it's reached the firewall, then reach the filter here, it will be transformed into the payload that you expected. So how can we use this one now to actually bypass firewall? We will go through it a bit quick in the lab. Okay, so now we're going to bypass this firewall by using transformation. So within our payload, something will be transformed. As you saw on the example before, when we send a hex or Unicode, etc., it will be encoded into original character that we want. In this example, it's the same. If we look at the source code, just to see the vulnerability, it's vulnerable for a server-side template injection. So we're sending our payload right here, which will have our value. If it contains WAF blocked, which is if the firewalls detect something, it will return the firewall page. Otherwise, it will take our data, convert it to bytes, and over here it will decode it and have the Unicode escape argument. So this allows the actual payload or a payload to transform. If we do a hex or Unicode, it will be transformed into the real character. So then it will take this page. So here's the actual real vulnerability of the template injection. It's taking page and it's going through the environment, which is the top here. It's getting this file, which is initial.html, and it's rendering it, and the output variable within this file will be replaced by data, which will be our decoded payload right here. The actual issue is right here. It's printing out the content, and it's using Jinja to actually take a string, which will be the page itself, the page content, and it's rendering it one more time. So if our payload contains server-side template injection payload, it will execute it. Okay, so that's vulnerability right here. So we will take advantage of this behavior right here, which allow us to have send hex encode or Unicode, and it will be transformed into the real character. This will also happen, for example, if you're inside an evil statement in a vulnerable application and you send a hex or Unicode, it will be the same effects. So if we try here, just sending a test, we want to see the reflected input. It's the same reflected as before, it's in the value. Okay, cool. We're going to check a bit quick on the firewall here. So it sees, if it's not see a letter, uppercase or lowercase, a digit or underscore, if that's not our character combined with a curly bracket, a regular bracket, or a parenthesis opening, it will be treated as malicious and it will get blocked. So our goal here will be to bypass the firewall by exploiting the transformation that occurs in the backend of the vulnerable application. Okay, so we will first try just to trigger the firewall. So we can do this if we do, for example, it should not trigger if you do a curly bracket, and you can see it do not because it's actual letter T. If we do, for example, a dot, it's triggered because it's a special character. Every special character, for example here, will get blocked. So $sign or 2 curly brackets in a row will get blocked. So we need to use this transformation here to actually bypass this firewall rule. So to do it, it's quite simple. As you might expect, it's just hex encode, which will be 7B. And we will see if this actually transforms into curly brackets. And you can see here in the response that it actually do. Render it and you can see it's transformed successfully, right? So currently we're in here on the code line. So, or we're actually here, but here our payload will be transformed into this. So if we're sending this one out, we don't need to encode it one more time because it's a B, so it should be allowed, right? Cool. You should be able to do full. Yeah, okay, cool. So we're able to do full here now. If we do this, I think it should be an arrow. Yeah. So we're having an arrow here because Genia did not understand what it should do with our value. So we actually triggered the template injection payload, or the template injection vulnerability rather. If we do 7 multiplied by 7, which is the most common payload, and send it, we get 49. Okay, cool. And we actually bypass the firewall. So this is a proof of concept as well. If the characters are being transformed by the application, the firewall will having an impossible, like it will be impossible for the firewall to detect it, because unless it's actually configured to also check for the different encoding version of the character, then it can block it. Otherwise, you bypass it, right? But it's also an issue that I will go more into detail in other labs if it's allowed different encoding supports. Like if it should support this encoding support, there is a lot of other problematic issues that will happen. But for this one, we bypassed it with simple hex encode, and yeah, that broke the regex, and we're able to execute a template injection. Okay, so we currently did the transformation lab, and we will move on to the next technique. So the next technique is one of my favorite, and that works extremely well with firewalls. It's when you exclude spaces and manipulate spaces in a way that I showed you recently or before in the presentation when I showed you the actual SQL injection. I show you how you could take the simple SQL injection and how you removed every single space within it and combine it with comments and parentheses, and yeah, combine quote, single quote, double quote, cluster it with keywords. So right here are some example of payloads. You might don't know every of them, or you might know all of them, but I just wanted to showcase some of the payloads, like the power of like not using spaces, how many possibilities there are without spaces. So like in XSS, you can, for example, use /, you can use new lines. For example, on the right SVG payload on the top right, you can see it's combined with the red double quote combined with unload directly. You can see basically everything that is red marked is replaced or used instead of a space. So what we're going to do now is we're going to send a simple payload like this to the firewall. if we send a payload like this, it will probably get blocked because it's not a super stealth payload, right? So as you saw in the example here before, on the bottom, you can see instead of using spaces, you can use a ton of different things. You can use the variable ifs, or you can use a closing arrow to actually send data from the file directly to cat that will output it. So the payload here, if we take this payload and combine it, or not combine it, which we change it into actual payload like this instead, what will happen when we'll send this to the firewall is that it will getting a lot more difficult for the firewall to understand the actual payload. So in this case, depending on the configured firewall, but in this case it's actually harder for the firewall to see when something within the payload starts a new section. For example, if you had it on the old payload, when you had the space, it's easy for the firewall to see that cat is separated by etc passvd. In this case, when you're having an arrow sign, it might be a bit harder for the firewall to actually see that they are separated. It might think that cats are combined with like the arrow sign and the forward slash, or it's like it's having a harder time to actually understand the payload itself because it's clustered together. So there are also advantages of using spaces. So spaces can be used to bypass the firewall as well. For example, like this. The same scenario, but the opposite will be like, instead of it actually having a hard time to detecting when a new section starts, we will make it think a new section starts. So in image src on load equal on error alert, here we're having a space between the actual equal sign and the alert statement. So we want to confuse the firewall into thinking that on arrow equal is actually an empty value, and actually alert is an attribute that is invalid. That's what we want the firewall to think, right? So this can confuse the firewall and bypass regex, because on arrow can be seen as an attribute with an empty value, for example, as I mentioned, and alert will be a completely new attribute. So we're going through a fast lab on how you can bypass this by using these techniques. Okay, so we will go through this lab here, which is vulnerable to SQL injection. And if we read the description, first of all, we need to bypass this firewall here without using space, tab, or new lines. And we need to extract a flag here, which is within the admin's note. So the users store a note in their database, and the admin's note will be the flag that we want to extract. So the flag will be in the format of flag and 4 digits. So for example, flag 1234. So if we're checking the source code real quick just to confirm the vulnerability, as we always do, we can see our payload is taking from here and it's reflecting directly here. So result, select username, note from users where username equal to guest, and note like payload. So if we do, for example, nothing, it should result in everything, like everything that is true. So we're submitting this, and you can see the result will be here. From the guest has to note just a simple guest user. Okay, so if we do, for example, simple, which is a keyword, it will result in the same because it's checking keywords within this note. So what we want to do here is we want to, for example, write a new statement. So we will do either you can do something false and then you do or, and then you do your select username or note from admin, this kind of stuff. But if you actually check the blacklist here and inspect, or XOR and AND is going to get triggered by the firewall. So if we do, for example, set, and then we do or, first of all, it's triggering the or. And in this regex here, that is another filter, it's actually removing the space, tab, and new lines. So, but first of all, we need to focus on one thing at a time. So we're going to focus on the blacklist. We want to bypass this here. So instead of using or, XOR, and AND, you could use bitwise, which is just a simple pipeline like this. But in this case, it's easier, in my opinion, to actually exploit the already known value that we knew is either false or true. Remember before I told you, if you're inside a where statement, for example, in SQL injection, you could take advantage of this value that you knew. And when you escape it, you can do this old value that you escaped from equal to the new statement. So you can make this old value true or false, and then you take your new value that you knew is true or false and combine it with old. I will show you. So if you do, for example, sed, which will be, if we send here, it will be false. No result. If we escape this one and not using any space, we could say this one is equal to 0 and then just comment away the rest, which means sed, which is false because it's no result, should result in 0, which is false. We can do it easy. We can do it like false like this as well. It doesn't work. It doesn't matter. You're sending it? Oh yeah, okay, it's true because sed is false, so it's false equal false is true. But for example here, you can do 1 to check if this one is actually true. So if sed is true, then it should result in a result, which is to not. It doesn't, right? But before we did false, and because sed was false, we actually check it was false, and that's resulting in true. That's why we got the result here, right? So if we do, for example, 1 equals 1 here, it will be no result, because this section here is true and this one is false. But if we remove the sed, we can see we got % signs, which means basically anything. And remember, when we didn't send anything, it was true before, right? So this here on the left will be true, equal to our new value, which will be 1 equals 1, which is true. Submit it, and you can see it works, right? So we bypassed the first one by taking advantage of the old. So this is really great because the firewall won't actually be able to see the source code of the vulnerable section on the code. So now we're exploiting the vulnerable section and making the firewall confused and bypass the first step. And the second step here, which will be the regex replace, it's removing all the tab, new lines, and space. Okay, cool. But we're not using it, so we're fine for the moment. So the second or the third protection will be any multi-line comment here will actually be treated as trigger as well. So if you're having a multi comment instead, if you want to, instead of a space which is getting triggered here, you might think of using a multi-line comment like this, but it's also getting triggered, so we can't use it either. But we're already using what we need here. You can see we're using parentheses, right? And remember, as before in the presentation, I showed you can use parentheses instead of spaces for the sleep payload, for example. So in here, if we want to, for example, do select, and we want to do select 1, it will result in true, right? And so this means that if we send this payload right here, it will actually result in true. So now what we want to do, if we want to actually extract the flag, because we've actually bypassed the first blacklist, we bypassed the space scenario, and the multi-comments is no need because we're using parentheses instead. So in here, we're going to select the note. Whoops. We're going to do the note, which you can see here will be within here, the admin. It will have a note. The flag will be inside the note. So select note from, and then inside here, you will have username. We don't need a username, do we? No, we actually do not, because we're taking all the notes from every user. We just want to actually extract the flag. So, sorry, we need first users, of course, we need a table. So, but we don't need the actual username, because we know the flag format, so we can simply do, like here, we can do where, and then we will have a value. So we will say where note, like, and then in here we'll have our value. So what we're doing here is we're selecting note from users where note having a value, and we can select %. This should be true, right? And it says no. Okay, so first of all we need to check here if this is comparing correctly. We can actually make, remember before we did 1 equals 1, we can do the same right now, but we're going to do 1 equals here. No result found equal to 0, more than 0. Select node from users where note is node, right? Yeah, and note, like anything, if it starts with an F, no. Let's see, this one value is true, if we do it false. Okay, yeah, okay. Gonna have it false here. So when this value is false, it will be equal to something that is, oh, sorry, it's true. 1, okay. Okay, so equal to a new statement over here. We're selecting the node from the users where node, like, and starting with an F. If this is true, it should result the result. Okay, yeah, it's resulting to the result, and we can see if we do an X, it's giving no result. Okay, so it's true. One of the nodes start with an F, right? So we can try this by just doing the full straight flag right away. And okay, so we confirm. Okay, we got a second injection and we're currently extracting the flag. So I will bypass it because we take advantage of here, taking advantage of the old value, and we're making it to a new statement over here. And I think, to be honest, I think the reason here is because it's different types. Yeah, it's comparing the types and also the value. So when we did before without this, it's actually comparing this one as a string on the left and this one here as a statement. So now we're extracting the flag. You know, we'll have curly brackets and we can move the % sign in here. That should be true. Cool. And we know it's 4 digits. So if we start with 1, or we can actually do it, okay, it's actually 1. Okay, I was lucky. So it's starting with 1. But if we do double % sign and we add any number here, so 1, we got a result true. So we know it's a 1. I will save it here at the bottom. So we know it contains the digit 1, we're checking 2, no, 3, no, 4, no, 5, yes, okay, so we've got a 5, 6, no, 7, no, 8, 8, we got an 8, 9, 0, okay, so 8 and 9. So we got 1, 5, 8, 9. Some combination of that digits will be the correct flag. So we're gonna try, is it starting with a 1? No. Is it starting with a 5? No. 8? No. 9? Yes. Okay. Is the second digit a 1? No. Is it a 5? No. Then it is an 8. Oh, sorry. 8. Correct. Okay. 5, 1, 5. Yeah, okay, so the last one is a 1. So that one should be the full flag. 9851. We're trying. Okay, cool. So we solved it. So right here, to take away is, instead of using OR, AND, or XOR, you can actually take advantage of the old one that bypassed the keywords. Instead of spaces, we're using parentheses, and that works flawless. And yeah, with all this combined, you're having a payload like this, which bypassed the full firewall because it didn't contain any space, it didn't contain any of the keywords, and yeah, it's resulting in successful exploitation and firewall bypass. So now that we took a look at this current lab, which was a SQL injection without any spaces, and we also managed to bypass the OR, AND, or XOR statements, we're going to step into the encoding process, which is quite cool actually of thinking about it. And I will tell you why, because it's not as simple as just encoding a payload and it will be decoded on the back end. You can actually use encoding to confuse the firewall in different scenarios, as I will show you here. For example, if you're having a payload like this, you can see the red mark in the payload. It's actually a HTML encoded version of the closing arrow sign. So, in this case, if the firewall sees this, it might actually see it, like here, as a closing image tag, which will result in the green one here actually bypassing the firewall. The reason for this is because the firewall sees an image tag and it also sees a closing of this image. So it thinks that everything that comes after this will be just pure plain text and no actual, not inside a HTML attribute or HTML tag, sorry. So this technique is extremely well, and I bypassed a lot of firewalls with this. Obviously I combine with other techniques. For example, if you combine this with space, as you can see, this one actually is, because it's using / instead of space at the beginning. So if you check on this one here, this is the different type, or it's obviously a lot more, but these are some of the common that firewalls do attempt to detect. The reason why this is so effective in firewall bypassing is because when you're sending something that we saw here, the arrow that is closing doesn't technically need, like, if it's not decoded in the backend application and the firewall sees it as it should be, like if it sees it as the original value, then it's actually bypassing a firewall, and because it's not decoded in the backend, it's giving no negative effect on the payload, right? So what you can use here is, you can use, for example, like ET, you can use an HTML encoder version, and you can use a URL encoder, for example, if it's not decoding the URL encoded version of it. And you can use it for different vulnerabilities. It's not specific to any, like quotes, for example. If you're inside a SQL injection, you can do a %sign, %27, and confuse the firewall into thinking, okay, now you escaped the SQL, like the SQL statement, but in reality you did not, because the backend did not decode it. So then you're writing a half payload to confuse the firewall, and then you're doing a real single quote, and then you're doing your actual payload. So the firewall will be focusing on the left part, which is just a decoy of your payload. And the other part will actually be the payload that is exploiting the application, but the firewall will not trigger it because it will be confused with the old decoy that you did when you actually encoded the single quote, which was not escaped. So I'm going to show you a quick lab on this one, because I think it's really cool on how you can use it and confuse the firewall. So in this lab here, the encoding lab, we will exploit the firewall, or manipulate the firewall rather, into sending an encoded version of a character that is being triggered or handled differently in the firewall detection system than it's actually being handled in the backend. So our goal is to, here, as you can see, the firewall supports a range of encodings to detect payload in different forms. We need to bypass the firewall by using a supported encoding that the firewall sees and detects, but the vulnerable application to actually not decode this. So we can see the payload here will be our value inside here. If we're checking here, it's going straight to the actual render section, so it's actually getting reflected directly, and you can see it's using the function onQuote on our payload before it's sending it to the render, or to Genia to render it on the response here. We can try this out to see onQuote is actually just URL encode, URL decode, sorry. So if we do, for example, tests %22, and then we do X, just to have it more clear, we're sending it, we're checking the source code, and we can confirm it's decoding our quote, as you can see here, and we can also confirm it's vulnerable to an XSS. So what we need to know now is we want to check this firewall and see what is actually blocking us from exploiting this XSS. Checking the blacklist first, inspecting it, we can see, okay, so it's keyword alert confirm prompt console print and throw. Okay, but we're not there yet. We're not actually executing JavaScript yet, so this one is not currently an issue. We're checking the other filter, which is looking like an issue, right? Just as a like a note, You could exploit this if you just do like simple on a click or autofocus, but if you want to stick to the lab and actually exploit this or use this technique, escape this input is the goal, and then exploit your XSS. It's also having the type set to text this time, so you can't use the image as we did in the previous lab. So our goal is actually we're going to make a new tag, HTML tag, and then we're going to do a full XSS payload. So in this section here, you can see it's starting with an arrow sign in %25% FreeC, which means if it sees an arrow sign or it sees a % FreeC or %25 FreeC, which is URL encoded version, double URL encoded version of the arrow sign, it will be triggered in this regex, and as long as it contains an onload statement, on onload, on arrow, on mouse over, on click, etc. within this tag, then it will be blocked. And it will continue to search for this until it sees a closing arrow sign. So if you do open image and then you do on arrow, it will be triggered until it sees the ending arrow in this URL encoded form or WURL encoded form. So if we now try here with 2522 and see if the application understands it and decode it to a quotation mark, it does not. Okay, so this application do encode URL encode one time, but the firewall do see WURL encoded as malicious as well. So because they are not synchronized, you can actually bypass and confuse the firewall, because the firewall do not know what the backend supports unless you specifically configure it to it. But in this case, it does not. It's triggered on WURL encode as well. And it's very common in real firewall if you think about it, right? The firewall has to be able to see a lot of different payloads. So when you're sending URL encoded, base64 encoded, HTML encoded, Unicode, hex encode, it has to detect a wide range of these different payloads because it doesn't know what backend supports. So, but it's also a downside because you can use this strategy here, because if the backend do not support it and you're able to smuggle in it within your payload, then you can confuse the regex or the detection process within the firewall to actually bypass it. So what we're going to do here, we're going to simply escape. If we're sending it here, we're escaping. Okay, so we're good to go to write a new tag. We're going to write an image tag, and we're going to test the actual protection, because you always test it to make sure it works. And then you're doing on arrow. Okay, well, we're already blocked. So we're blocked here, as you see. So if I'm sending this one, you can see we're blocked. So this one works, right? But if we're closing this image tag here in between, because it's looking until it sees an ending tag, then it's not blocked. But the payload do not work either, because if we're sending it, you can see we did an image tag and we're just plain text. But the firewall actually supports URL and WURL encode as well. And the application here supports URL encode. So if we will do %freec, free sorry, for the closing, it's supported by the firewall and it's also supported by the backend. So this one did not work. But if we actually do 25, if we can check the regex one more time, you can see it supports 25 FreeC. This one should be treated the same as all the ones we previously did within the firewall, but not in the backend. So we're sending this one, and we can see FreeC. So this one did not decode. So now all we have to do is adding a source here, and on arrow here should actually not be triggered anymore, as you can see, because the firewall thinks this one here is an ending arrow sign. So now we just want to bypass these blacklists, which is alert confirm prompt console. And you can do it because it's JavaScript. JavaScript is JavaScript. So instead of doing alerts, you can still do alerts, right? If you didn't know, you can do straight Unicode within JavaScript. So if you do \u for your Unicode, and then you just do the value of a small a or a lowercase a. This will be an a, and this will be alert. So alert, then we will have the parentheses, and then we do 1. And to see the execution, you do the I, and boom, we're able to solve the lab by using the confusion. So the confusion here is that it thinks the image itself is already closed, so the firewall thinks that everything that comes outside or after this encoded closing arrow sign will be treated as just normal pure plain text. But in reality, because the backend do not actually decode it, it will still be inside the image tag, and it will just be an invalid attribute. And the SRC will be an invalid source, so when it's getting on, when you trigger an arrow, you're just setting on an arrow and then you're setting your payload. And because JavaScript is as it is, you can just use pure Unicode to bypass the blacklist. Alright, so we just finished the last lab, which was the encoding. And together with this, we have done all this lab now with excluding spaces, we have done with encoding, we're done with filter collision, we're done with transformation, and all these techniques here that we learned are extremely useful in modern web applications, especially when you combine them and make them more advanced. Each lab have contained specifically focused on its sections, but in real world you can use one technique all up to all of them to combine your payload and to make your payload extremely stealth, right? So, as a conclusion of the full presentation, we have learned to understand a firewall's blind spots, where the firewall having a hard time to understand, where it's actually a malicious part and where it's not a malicious part by using these strategies. We have then mastering a new methodology when instead of sending full payloads, like fuzzing for payloads and bypassing, you can take one payload, send a full payload. If you get blocked, you then splitting the payload into different parts, sending one part and see if that part actually is the trigger of the actual full payload. Setting up a theoretical scenario and then remaking your payload as we did with the sleep 4 in the SQL injection. Taking the prefix, which was the single quote or parentheses, and trying to see if this is the actual first trigger of the firewall. If it is, then you modify it and remodify it until you actually bypass the first step of the firewall and continues to the full payload is done. Well, understand different techniques, which is the filter collision, transformation, encoding, and also excluding spaces from your payload. And combining this, I can assure you that you will bypass a lot of modern firewall configuration out there. And of course, you have now learned how you can use everything that I just mentioned to create your full own payloads. And I highly recommend you actually use techniques like this. You can take payloads like that is already done, but you modify them and customize them and make your own word list with payloads and detection payloads to actually use them yourself, because you're now having the skills to make your own payloads more advanced, more stealth, and get under the radar and detect vulnerabilities without getting false positive or blocked. So with all this I want to say thank you, and yeah, thanks for listening to my presentation.